In this small demonstration we show the usage of our Ethercat library for Labview for vibration analysis applications. We use the Beckhoff EL3632 Ethercat terminal to measure IEPE sensor data and turn into frequency spectrum. Our demo setup consists of 2 PC fans and 1 IEPE acceleration sensor. One of PC fans is missing one blade to show a difference in vibration behavior. A potentiometer is used to change the supplied voltage, which results in the speed of the PC fans. Each fan can be switched on and off separately. The fan speed will be read using the tachometer signal from the fans. The acceleration sensor is connected directly to the Beckhoff EL3632 terminal. It can read the acceleration with a rate of up to 50,000 samples per second to do frequency analysis. The Beckhoff EL3632 terminal connects directly to IEPE sensors, which use piezoelectric effects to measure acceleration, force or pressure. Microphones also apply to the IEPE standard. It has 2 channels, which can be sampled with up to 50,000 samples per second per channel. The sampled data is made available over Ethercat bus using oversampling technology. We also use a Beckhoff EL3102 analog input terminal to read the tachometer input of the fans and calculate the speed. What does oversampling mean in Ethercat? In an Ethercat topology, a process data frame is collecting the process data from the slaves in a defined cycle time. So normally the bus cycle time is also the sample rate. To achieve higher sample rates than the bus cycle rate, a slave can sample with a higher rate and insert multiple samples in the cyclic data frame. In our case we use a sample rate of 50,000 samples per second and a bus cycle time of 1 millisecond. So the EL3632 will have 50 samples in the cyclic data frame each millisecond. We have created a simple Labview software that uses the Ethercat library for Labview in real-time mode to read the measurements from the PC fans and do a FFT frequency analysis. On the left side we have an online view of time domain measurement and the resulting frequency analysis. Also the speed in RPS and RPM as well as the voltage level is displayed. On the right side we can take shots of averaged frequency measurements over a defined period of time and compare them. Here take a look at the Labview block diagram. Using the Ethercat framework and driver libraries for the Ethercat library for Labview, the programming is very simple. After starting the master, the 5th order filter and excitation voltage configuration is written to the EL3632. Then in the main loop the acceleration data is read continuously every 500 milliseconds. Each cycle the frequency spectrum is processed. Also the 2 channels of the L3102 are read to acquire the fan speed and voltage. In this demonstration we only want to show the capability of doing vibration measurements using Ethercat fieldbus technology. In the scope of the presentation we will not perform a real specific vibration analysis. We currently see our normal PC fan running with a speed of 50 RPS. This corresponds to what we see in the frequency spectrum with a peak amplitude at 50 Hz. Also we see the effect of the 4 motor coils in the PC fan that results in a frequency peak at 4 times the speed. We take an averaged shot of the frequency data. Now we run the fan with the broken blade at the same speed and take a measurement. We can now compare the frequency data and the plot and go on with any further analysis of the data in Labview. Thank you for watching. For any questions or remarks, please leave a comment below or contact us using the communication channels in the video description.